theory. Valence bond theory. So from here only we start the concept of the overlap of the atomic orbitals. In short form is called VVT. The valence bond theory was proposed by H.I.T. Hitler, not Hitler. Hitler and London, and was later modified and developed by Linus Pauling. He is a very famous person. He is called the father of chemical bonding. He awarded the Nobel Prize twice. And Slater. The valence bond theory is based on the knowledge of atomic orbitals and electronic configurations of elements. Overlap criteria of atomic orbitals and stability of molecules. Right now.
So done.
Okay. One minute. Let me put some ink in my pen. Okay. So now I'll discuss. They remain in the gaseous state now. They remain always very far away from each other. But they have kinetic energy and they can move. Say you have taken hydrogen. This is hydrogen atom and this is another hydrogen atom. I write here hydrogen A and hydrogen B. So they are very far away from each other. So when they are very far away from each other, they do not have any mutual attraction and repulsion. Okay. So this hydrogen A is having this is a structure hydrogen. See here. You have now nuclear, this is a new proton you have, and this is the electron. So I'll write here now. PA and PB. This is PB and PB. Now I'll write here. Forget, I'll write here HA and HB. So when they are very far away from each other, there is neither attraction or repulsion. Then gradually what will happen? They will come nearer. So this is EA, this is HA and HB. I'll put one plus, the proton is there, and this. When they come nearer to each other, what are the things you're going to find? What are the things are there? So there will be, when hydrogen atoms approach each other, two types of interactions are observed. What are those? That is attraction and B, repulsion. Okay. Now, can you tell me where you can have attraction? When they are coming nearer to each other, there are two types of interactions are there. Attractions are there and repulsion is there. So can you observe from here? What are the attractions it can have? Okay. Now so we go for attraction. What is the attraction? You'll find here. The nucleus of A will be attracted. Nucleus is positive charge, will be attracted towards the electron of B. Okay. Nucleus of A will be attracted. No, I will not write like this. I'll write here. Electron of B. It is EB. Will be attracted by nucleus of A. This is A plus is 1. Similarly, electron of A will be attracted by nucleus of B. Sorry. Plus. No, I'll not write H. It's very confusing. I'll write here A and B. Plus. And here I will write plus. So this is the attraction. And B. Repulsion. You know similar charges repel. It would be electron of A, that is EA minus, will repel electron of B, which is EB minus. AJ. So here I'll write here HB. Hydrogen. No? Okay. And second, nucleus of HA. So how do we write here? Na plus will repel nucleus of HB. NB plus. Okay. So let me draw it in a diagram. This is HA. This is HB. This is Na plus, NB plus. Okay. This is TA. This is TB. Okay. Now see here. This will be attracted. This. So I had put attraction sign in this way. So it will be attraction. And this is the repulsion. This is the repulsion. Right. So forces are acting now. Is the repulsive forces and the attractive forces. Okay. So when the attractive forces overcome the repulsive forces, the overlap of atomic orbitals of two different hydrogen atoms takes place, resulting into the formation of a covalent bond within them to form H2 molecule. Now I want to draw it in a graphical way. See here. See, this is the potential energy. Because everything, all atoms, they combine with each other to reduce their potential energy. And this is the internuclear distance. Internuclear distance. Okay. So now, in this case, the two atoms were approaching each other. Okay. So when they are approaching each other, repulsion did not start. All right. And gradually they were approaching each other and suddenly you find the potential energy is increased. So I'll show you. This is the case where HA and HB were far. Here, see, as I told you that when the attraction becomes more, then all the overlap takes place. Now, what is this? What will have here now? In this case, sorry. They were coming close. Here, they came further close. So, in this case, here you will find the orbitals start merging with each other. Just like we go for handshake. Here you will find, in this case, you will find HA. Please draw it nicely. Huh? Now it has come for maximum overlap. Then why suddenly it has come? Here. So I'll do it like that. This is Na plus and this is Nb plus. Here you have Ea and here you have Eb. Now if the orbital overlaps more, then the two nucleus become too close. When they'll be too close, there'll be huge repulsion will be there because nucleus is just very small space but highest the density of positive charges. When you try to overlap more, then there is so much of repulsion, immediately the potential energy is decreased. Okay, so now, then what is this? See, this is the place. What is this now? This internuclear distance, this internuclear distance is the bond length of H2 molecule. So this is the graph. Okay, that is, they will be coming very far. Gradually, when they are coming nearer to each other, the attraction and repulsion occurs. When the attraction become more and more, then they will come like this, and they start overlapping by this way. But the overlap will be like this, but further overlap will not take place. If you think this is the nucleus and this is the nucleus, if you bring them very close, then there will be repulsion. All right. So this will be the chemical bond between them. This is the one which is being mentioned by valence bond theory. But please draw it little nice. It is just like that. It is just like human being. How do you form relationship with people? We meet many strangers in our life. Okay, so when a person is a stranger, we do not immediately trust them. But even if you may not trust them 100%, but we also don't dislike them. All right. Then gradually, with the time when you come closer and closer to the person, then you find no, his good qualities are more than bad qualities. Then only we make friendship. Okay. So friendship is a bond between bond. All right, two persons. So this is the same way the valence bond theory is being explained. Okay. Now let me write here the basic assumptions of valence bond theory. basic assumptions of valence bond theory. Okay. 1. Atoms do not lose their identity. Atoms do not lose their identity. Even after the formation of the molecule. See, if two persons are friends, they have their own identity, okay? But they have relationship. What relationship they have? The relationship is nothing but friendship. Or in a house, it may be your mother and father have a relationship, okay, of as husband and wife. But individually, your mother has identity, your father also has the identity. The bond is formed due to the interaction of valence electron. Means only the outermost shell electron takes part in bonding. Valence electron. There are two atoms come close to each other. Close to each other. The inner electrons do not participate in the bond formation. Third, during the formation of bond, only the valence electrons lose their identity, because now they cannot claim they belong to certain atom. They belong to both. Lose their identity. The other electrons remain unaffected. The stability of bond is associated with sorry, the stability of the bond is accounted by the fact that the formation of bond is by the fact that the no accounted by the amount of energy released in this process. If the more energy is released, means more stable the bond is. The molecule has minimum energy at a certain distance between the I have shown you with that with internuclear distance, remember, between the two combining atoms. Such distance is known as internuclear distance or bond length. I discuss a little bit more. When two hydrogen atoms comes nearer to each other, see, when a hydrogen atom has come nearer each other, they form hydrogen molecule. So next to hydrogen is helium. Okay, when two helium atoms come nearer to each other, then you should have got He2, but it does not form. Why it is like? Okay, see here. helium is having 2 protons and 2 electrons. Okay? Don't you please see. It is not given in your book. Two electrons. And it is having this. So what are the attractions you have here? Attraction is that this is being attracted to this is being attracted to this. This is being attracted to this. Okay? This is being attracted to this, and this is the attraction you have. This is attraction. I'll write here now here how to write the attraction. I'll change it here. I'll write a small. Okay? And here I'll write small. Okay, attraction I'll write it with capital A. Now let's see repulsion. See here. Similar charge. This is repulsion. R. This is repulsion R. All right. Now, here in this case, you'll find this is repulsion. Here, repulsion is more. See, you have 2 positive charges. All right. So let us count the repulsion. How many repulsion you have here? Yeah. 1, 2, 3. Attraction 4. Okay. Now, they mutually repel each other. They mutually repel each other. Okay. Now, this is being repelled by this. This is being repelled by this. So how many I should write? It's getting complicated, na? See here. So in this case, what happened? Helium does not form HU2 molecules as these. Okay, I'll remove this. I'll remove this. Okay. Repulsive, others are there. As repulsive forces is more than attractive is will not be R. More than attractive forces. Draw this nicely. Electron will repel, and nucleus will repel. And nucleus of one will be attracted by will attract the electron of others. তোমার যে দিদি সব কইন তুমি তো বুঝো কিন্তু তোমার ডাউট হলে দিদিরে জিগাও না কালকে দিদি আমার উপর রাগ হয়েছিল তোমার দিদি হলে আজকে জিঙ্গা তোর হয় জিঙ্গা লয়ে গেলে জিঙ্গা তোর ও খারাপ এটা দিদিরে কইলেই হইতো না ঠিক আছে তো দিদিরে কইলে তো দিদি জিঙ্গা খারাপ হলে different types of covalent or different types of overlap. So we'll go for now. orbitals overlap. See, orbitals overlap. আগে তুমি ওই মিষ্টি কুমড়ার ডাটা কুমড়া হাঁটো তারপর orbitals when they overlap then only lead to the formation of chemical bond. Overlapping of atomic orbitals lead to the formation of chemical bonds. Okay, now we will see how many types of orbitals overlap can occur. How many types of orbital overlap can occur? That you also can do it. Yeah. Generally, the overlap of s and p orbitals lead to the formation of chemical bonds. All right. While overlapping takes place, symmetry of the orbitals has to be maintained. I'll discuss with you, don't worry. What is the symmetry of the orbital? See, when you meet two persons, we shake hand with each other, is it not? But when you go for shaking hand, we obviously you do not go for, you will not go and shake his leg. This is called symmetry. Okay. So now, first we will go for sigma bond. Okay, right.
Sir, done.
Then we go for types of covalent bonds. Covalent bonds are of two types. It depends upon how the overlap is taken. One, we call it sigma. Watts. And second is pi or pi watts. Now what is sigma bond? Let us see. Sigma bonds. This type of covalent bond is formed by the end to end. This is a phrase, end to end. Or sometimes we call it head on. I'll not put here in bracket. I'll keep it outside. Or head on overlapping. Along the internuclear axis. And is known as sigma sigma. So I'll show you what are the different types of sigma bond you can have. Types of sigma bonds. Okay. See here. We'll call it name. I'll not right now. I'll show you. See. Look at this. The shape of what orbital? How does this orbital look like? Spherical orbitals are what? We have discussed about the shapes of orbitals in atomic structure now. So the orbitals which are spherical, what do you call that orbital? Hello? Huh? chapter पढ़ लिया. Tell what is this orbital when you write spherical orbitals?
S.
Very good, girl. So this S and S. Okay. So we'll now here we'll write here S overlap. So now you know valence bond theory, they will overlap. So what we'll write now here? This. So we'll write now here SS overlap. Okay. In this case, the symmetry is spherical orbital, so there's no question of symmetry. If you wish, you can write positive. So this is SS over. You write here SS over. See, here you have to maintain symmetry because one lobe will be up and one other lobe will be bottom. Okay? So plus and minus does not indicate the presence and absence of electron. It is a question of symmetry. Okay? Just like that, when we stand, our head is on the top and the feet are at the bottom. All right. So both of the part of the body, it does not look symmetrical. It's just like this. So this is symmetry. So this is S and this is P. So we write now here SP over left. So how you are going to get? You will get it like this. Okay. So this is SP over left. Okay. Achha, now SS overlap example. What example I can give? SS overlap is hydrogen H2 molecule is this H2 molecule. S orbital, 1s orbital of hydrogen overlaps with the 1s orbital of the another hydrogen to form hydrogen molecule. So here you will find in this case, so I can write here now H and it will give you this. Then see here, if it is hydrogen and if it is chlorine. Okay, chlorine has, is the electronic configuration is chlorine is that last high orbit. I'll say it is 3s2 3p5. That is one of the electron of the p is less in the p orbital. So one unpaired electron is there in the p orbital. So that unpaired electron is going to combine. So example is what? Example is what? HCl. So in this bond is sp overlap. So write here now class. So here you can write class. Now see. So in this case, it is P. So here plus and plus will overlap, or minus and minus will overlap. Plus and minus will not overlap. Okay. So in this case, you will find this and this. So it is plus PP. Will be overlap. So how it is possible now? Chlorine, chlorine. So you'll get here now Cl2. So in case of chlorine molecule, if the p orbital of one chlorine overlaps with the p orbital of another chlorine to give you chlorine molecule.
So done.
Okay, now we'll go for pi bond. Pi bond. So this type of covalent bond is formed by the sidewise overlap of the half filled. Half filled means what? It will have one electron. Half filled atomic orbitals. See here. This is one pi bond and this is another pi. This symmetry has to be. So what it will give you in this case? Like this. It's like this. Okay? So plus. After the formation, you know how does it look like? Because this is a nucleus. The nucleus cannot come so close with each other. So this orbital will look like. Okay? This orbital will look like this. Yeah? So this is not two bond, only one bond. This is plus overlap and this is minus overlap. Sigma bond and this is the pi.
So done.
And so please remember, which bond is stronger? Sigma bond is stronger. Sigma bond is having the maximum overlap. Okay, maximum overlap is stronger. But in case of pi bond, see, sigma bond is just like our handshake. See, if you hold it like this, handshake, you have maximum overlap. So it's difficult to remove one hand from the other if someone pulls also. But the pi overlaps are like this, like this. Okay. So in that case, anybody pulls, the hand will be separated. So we'll write now here. Sigma bonds are stronger than pi bonds. Yes, the former is formed by maximum overlap. Maximum head on overlap. While the latter is formed by weak sidewise or lateral overlap. Example I can give you. Let me take 2p orbital. See here, you have maximum overlap. See, this is sigma. But in case of pi, see, overlapping zone is very less. So, it is stronger than this. So we have learned that we can have sigma bond in 3 ways. SS overlap, SP overlap, and PP overlap. And we can have pi bonds by the overlap of the by the p orbitals. Later on, I'll tell you there are three types of pi bonds are there. Pi bonds you can find by formed by. Okay. Okay, I'll write down. So there are 3 types of sigma bond. Okay, I'll write now here. 1 SS, 2 SP, and 3 is PP. So this is we have already discussed. Now there are 3 types of pi bonds. Okay, 1. I'll write here now. P pi bonds. Don't get nervous. This is the one, P pi. So it is being formed by, my drawings are also so bad. See, this is P and this is P. So this is P pi. Then second one is P pi d pi. So it is p orbitals, d orbitals. Remember, I drawn it in this way, double shape. See here, this is plus, this is plus, this is minus. Let's see, symmetry is maintained. And third one is d pi. So it is This is I'll give only for your entrance. See here it is plus, plus, minus, minus. So this is plus, this is plus, this is minus, and this is minus. Is it that any type of overlap will result in the formation bonding? No. Types of atomic orbitals. There are three types. Positive overlap, which goes for bonding. Negative overlap, no bonding. And zero overlap also, no bonding. This is positive overlap. Okay. Symmetry has to be maintained. If symmetry is maintained, positive. Okay. This is positive overlap. For this one, you have to understand this. See, these are how many p orbitals we have? We have 3 p orbitals. See. So this and this is this. Okay. So it is X, Y, and Z. Z axis. See here. So you think it like this. I cannot change my finger. Huh? This is Z. This is Px, series Px, and this is Py. We know sigma bond can only be formed by what? By the head-on overlap. If it is head-on, this will be side. This will be side. Okay. So out of the 3 p orbitals, only one can form sigma, and others will form the pi orbitals. Okay. So this is I'll write here now. Pz, and this is Pz. So let me write here it is Px and Px. So if it is like this, then Py I write like this. Do 90 degree to this. Okay. So all right. So these two are what? This is sigma, and these two are pi. This is positive overlap. Now negative overlap. This is negative. This is not going to form bond. This is not going to form bond. Now this is not going to form bond. Symmetry is not matching. So I'll write here it is PZ, PZ, PS, PS. This is PX, this is PX. This is PY, and this is PY. So there cannot be any bond formation. Now what is zero overlap? Zero overlap means it is overlap taking place where no electrons are there. Say here. This electron is there, electron is there. But in this point, the electron is not there. See here now. S orbital by mistake, it did not go there or did not go there. It has come here. All right. So in this case, this is zero overlap. Second, this is this. And see, here electron is not there. When it comes like the overlap is there. But if suppose it is like this, if it comes like this, instead of this, if it comes like this, see here, no electron is here, no electron, here, no electron. So this is a zero overlap. All right. Thank you. Up to this much.